let's go ahead and do chapter 2. Chapter 2 will, if you look at the periodic tables here in the room, at the end of this, we will understand why in the world they look like that, hopefully. But let's go back to what we said earlier about atoms in general, just to review. Remember that atoms really are not little electrons in orbits. We said that they are actually best described as an electron cloud with a little wee tiny nucleus in the middle. This nucleus has 2 protons and 2 neutrons. We know that that constitutes most of the mass of the atom. We know that atoms are incredibly small. If this was a copper penny, it would have roughly 28 sextillion atoms in it. Huge number. The mass of a proton is very small, about 10 to the minus 24 grams. And again, that's all these zeros in front. We're moving our decimal place 24 spots. Our proton is about 10 to the minus 24. The neutron is about the same. And the electron is much, much less. We said if we have a substance that has only one type of atom, that we call that an element. Now the element is represented by a chemical symbol. We've seen some of those. And in this section, we'll see some exam questions from the old days relating to chemical symbols, so you get a feel for what you're doing here. Chemists have classified elements according to chemical and quantum properties, and these are represented in table format as the periodic table. Now that's the periodic table right here. Originally, as I said, the periodic table was devised back in 1872 by a Russian named Mendeleev, based on chemical properties. And this is kind of amazing. These, again, the chemists back in the old days were just darn good. An example. We saw this demonstration with potassium. This is lithium. If you take lithium and you put it in water, it also reacts. But if you note, as it's reacting, it is just walking around fizzing, so it's evolving hydrogen. But it's not really exciting. If you take sodium and do the same thing, plop it in there, this is more exciting. This gets hot enough that the sodium melts and it forms this little sphere that bounces around the surface. And of course, potassium was the most exciting because when it reacted, when sodium finally finishes, when potassium reacts, it generates so much heat that the hydrogen gas that's being formed reacts with oxygen and literally burns. Well, this is what we mean by chemical properties. And based on this, Mendeleev came up with a periodic table that looks something like this. Now, he misspelled table, of course, but, and also misspelled group, and I guess that's supposed to be period. He was Russian. But you'll note here that for metals that form 2 metals and 1 oxygen, he was able to place lithium, then sodium, then potassium, etc. Cesium is down here. Cesium, if you put it in there, it reacts so violently that it explodes the second it touches the water. So we don't have to spell it out. So this was actually an amazing undertaking. Today, we represent the periodic table this way. Again, we're going to talk about the 8 groups going across, even though there are 18. And we have 7 periods going down. Let's just do a very simple thing here, and using this as a grid, do a couple very simple problems. What atom is found in group 1, period 4? Yeah, that's it. We go here to group 1, go down to our 4th period. This is K. Remember, K is potassium. Group 2, period 6. Go to your second group, go down to the 6th period, yeah?
I don't know if you pronounce it right.
Barium. See, this is fun. Group 8, period 4. Well, all the way over here on group 8, down to 4. KR, what do you suppose that is? Nope. Not kryptonite. It's krypton. Now, on an exam, I probably wouldn't do a question this simple, but I might do something like this. Silicon, arsenic, bromine, barium, and cobalt. Which are these? Silicon. What do you think silicon would be? Si. Well, see, now we can rule out these two. This has to be B, C, or D. Arsenic. Now, it's either going to be AR or AS, isn't it? It's AS. So we're down to 2. Bromine. BR. Well, okay, they're all BR. Barium. We just barium. Just did it. Those 2. And finally, cobalt. Cobalt is a CO, making it D. Which of the following has 2 letters? Fluorine is not FL, it is just F. Phosphorus is P, oxygen is O, nitrogen is N, and that leaves only our friend silver. Na, we all should know this one by now, we've seen it. Na is not neon or potassium or nickel or nitrogen. It is, of course, sodium. Here's another one. See if you can figure this out. Copper, chlorine, cobalt, carbon, and cadmium. Well, copper doesn't have a U in it anywhere, does it? So, of course, it's going to be Cu. Now we're down to A, B, or C. Chlorine. Chlorine is Cl, so we're down to these 2. Cobalt, Co or C8, what do you think? Co. And I think that narrowed it down. Carbon's a C, cadmium is a CD, and B is our answer. Which of these has 1 letter? Iron is Fe, antimony is Sb, tin is Sn, sodium is Na, only phosphorus. And finally, what is potassium? My gosh, everyone better get this one. It is, how else would you spell it? It's a K. Calcium is the original name for it. All right. So we have elements. They're in this periodic table, in a funny shape, and they all have symbols. Every element is assigned a number. This is called its atomic number. This represents the number of protons in the nucleus. The one thing that defines what an element is the number of protons. Doesn't matter how many neutrons it has, doesn't matter how many electrons it has. If it has 6 protons, it's a carbon. If you look at the periodic table, all of these are arranged by number of protons, or atomic number. Now, we can show this using what's known as an atomic symbol. Atomic symbol is a simple concept we're going to use again when we do radioactivity. Okay? When you write an atomic symbol, all you have to do is write the symbol for the element. Then we're going to put a superscript and a subscript in front of it. The superscript is going to be what we call the mass number, which is just the sum of protons and neutrons. Remember, that's where all the mass lies. So you add up protons and neutrons. For our subscript here, we're simply going to put the atomic number or the number of protons. That's all in the world it is. Now, you know, the concept of atomic symbols was introduced before there was word processors. And by putting them both in front, one up and one down, it's almost impossible to type it in Microsoft Word. But that's just the way it is. Go ahead, take this little set of data and do atomic symbols for hydrogen, lithium, helium, and beryllium. Hydrogen, our symbol is H. It has atomic number of 1. And we're going to say this guy has no neutrons. We would write H for our symbol. The mass, remember, is a sum here, so that's 1. And the atomic number, number of protons, is the subscript 1. Lithium is Li. Go ahead and write the symbol. We have 3 protons, 4 neutrons. Add those together, gives you 7. Our atomic number, number of protons, is 3. Helium, our symbol is He. We have 2 protons, 2 neutrons, add them together, that makes 4. Atomic number of 2. And beryllium, our symbol is Be. We have atomic number of 4. We have 5 neutrons. That's 9 with a subscript of 4. Now I did all the easy ones here. Go ahead and do these. Oxygen is an O, carbon's a C, potassium we know is a K, and iodine is I. Quickly jot them down. Oxygen is O. 8 and 8 is 16. We have 8 protons. Potassium, K. We have 19 and 20, that's 39, right? With an atomic number of 19. Carbon, 6 and 6, that's 12. Atomic number of 6. And iodine, 53 protons, 74 neutrons. That's some number. Oh, I don't have a calculator. It's 127. Very good. Atomic number 53. Exam question here. Mass number of argon is 40. What I asked was to identify the group, the period, number of protons, number of neutrons, and write the atomic symbol. Step one, you have to find argon, don't you? There it is. All right, so argon is here in 1, 2, 3, our third period, right? It's all the way over here in number 8. Its atomic number looks like it's 18, right? 18 protons. If we have a mass number of 40 and 18 of them are protons, how many are neutrons? 22. So put this together and write the symbol. It's AR. Our superscript will be our mass number of 40. Our subscript will be our proton number of 18. That was so much fun. Let's do it again. We have a neutral element here. So it's neutral, okay? And I tell you it has 12 electrons. Its mass number is 24. Well, how in the world do you figure out what this is? Think about it. If it's neutral and electrons have a -1 charge, then it must also have 12 positive charges, right? That's protons. Therefore, the atomic number must be 12. We're dealing here with magnesium. All right, our period, that's going down, so that's the third. It's in group number 2. If it has a mass number of 24 and 12 of those are protons, it has 12 neutrons. So our symbol would be Mg, our superscript would be 24, and our subscript would be 12. Any questions? Well, this is kind of a simple, fun exercise, isn't it? Hmm? This is fun. That's why I made a tutorial out of it. All right. In this guy, you're given some stuff, and you just have to fill in the rest of the blanks. There's a little button here you can click to get a periodic table, if you don't happen to have one. Okay, so let's look at our periodic table. Te is tellurium. Technetium is TC. Tellurium. So we look through all these little letters to find a TE. Anybody see it yet? I think it's down in here somewhere. There it is. All right, its atomic number is 52. That means it has how many protons? 52, right? If the mass number is 128 and 52 of them are protons, simply subtract it to get the number of neutrons, and that's 76. And finally, the charge. If we have 52 positives, 55 negatives, what's left over? 3 extra negative charges. "52 protons, 128 is our mass number, 52 minus 55 minus 3 for our charge. Bi is bismuth. We have a charge of +3, and we have 127 neutrons. Fill in the blanks. First, you have to find it. Bismuth is going to be way down at the bottom here somewhere, I think. There it is, at 83. If the atomic number is 83, how many protons? 83. If we have 127 neutrons and 83 protons, what's our mass number? Add them together. And finally, if we have a charge of +3, that means we have 3 extra protons, don't we? If we have 3 extra protons, that means we must only have 80 electrons. Do one more. U for uranium. This is uranium-235. This is what you use if you want to make bombs. And I tell you, we have 92 electrons. So you know the drill. Find uranium on the periodic table. Well, look as you might, it's not here. That's because this is only a partial periodic table. We're missing these guys at the bottom. Now we'll talk about why they're at the bottom. But if you look at that, down here, what's called the actinides, there is uranium at 92. All right, so we know that uranium has 92 protons. Write that in. If our mass number is 235 and 92 of them are protons, how many neutrons? Simply subtract. Now we have 92 electrons, 92 protons. What's our charge? It's a 0. Any questions? Yep.
For the exam, will we have a periodic table?
Oh, I'll give you one. You can take it home, laminate it. Fun thing.
But we can't bring it for that thing.
Oh, yeah. All right. As we've looked at periodic tables, ignoring, of course, the ones in our room, you may have noticed that they're colorful. Why are they colored? Well, because elements are grouped into things describing their properties, their chemical and physical properties. These guys that are all shown in blue are referred to as metals. They do things like conduct electricity, they're malleable, stuff like that, things that metals do. Over here we have a group that are yellow. Those are called nonmetals. They are insulators, if you will. They do not conduct electricity, they are not malleable. Their chemical properties are totally different than metals. So these guys over here are the nonmetals. Now here, at the border, we have a group that are called the semimetals. These are the semiconductors. So they're sort of like metals and sort of like nonmetals. Semiconductors, they're also called metalloids. Boron, silicon, germanium, arsenic, antimony, and tellurium. These are the classic ones. If you look at these periodic tables here, you'll see a little jagged line running down, kind of separates metals. Semi-metals are here, and non-metals are over here. There are also words that are used to describe things within the periodic table. These guys on this side and this side are referred to as representative elements. Now that's a very old term. I don't use it, but some places do, books do. Representative elements at one time were thought to be the things that you commonly found in living organisms. Now it turns out that darn near everything else is in living organisms too. But historic term. In between the groups of representatives, we have what are called the transition metals. The transition metals have properties that, for instance, in this period, vary between, starting with calcium, all the way over here to gallium. They a continuum of properties of all metals, but it's a transition in between the two representative groups. These guys are the inner transition metals, and these guys, these are standard transition, these are called inner. The reason that these are drawn down there, if you actually look at the atomic numbers here, these elements fit in here after lanthanum and actinamide. That's what they belong. But if we did that, we would have a periodic table that looked like this. And this is ugly. It's ugly and you can't put it on a poster and stuff like that. Plus, for a long time, nobody cared about these things anyway, so they just take them and put them at the bottom. Now, it turns out that these are radioactive elements, and of course, they are very, very important now. But traditionally, we just put them at the bottom. Other classifications. The whole thing in group 8 are called the noble gases or inert gases. That's because they don't react with things. Now, in fact, they do, but they don't react easily. You have to really beat them up to make them do anything. So because they don't react, they're referred to as being inert. The group next to it, very reactive elements. These are called the halogens. This will be fluorine, chlorine, bromine, iodine, and AT, whatever that is. These guys up here, these first four, please make sure you know those because we're going to use them a lot. Over here in group 1, these are referred to as the alkaline metals. Important ones to know again are the top 4. Next to them, we have a group called the alkaline earths. Probably the first 4 or 5 would be interesting as well. Now, this is the classic shape for a periodic table, but it's not the only. This is one of my favorites. You can take and wrap it into a circle. Same sort of properties. It's more difficult to find your groups and stuff like that. You know, here we are, lithium, sodium, blah, blah, blah. But there are lots of ways to represent this. Any questions? Well, let's just end with a few more examples. We have an atom of phosphorus. That's a P, right? Atomic number of 15, mass number of 32. How many neutrons? Well, come on, you can do this. What's the mass number? It's the sum of protons and neutrons. And it has 15 protons. Simple math, it's 17. Here is a symbol for bromine. Which of these is correct? This is the atomic number, right? That's the number of protons. So we're down to A, B, C, or the dreaded none of the above. If you add 35 and 44, what do you get? 79. That's our mass number. Yeah, but these are all the same. If this was not a neutral element, we would have to show a charge, wouldn't we? So it is a neutral element, so it must have the same number of protons and electrons. 35 protons, 35 electrons, and that's the answer. All right. We had 3 more tutorials today. That's 15 more points towards your exam. Don't blow these off. This is so important to your grade. It really is. Just work them, submit them. Density 1, density 2. Density 2 is more difficult, I know that. And protons, electrons, neutrons, that's not so difficult. Any questions? Monday is Labor Day. So if anyone's having a baby, that's today, I guess. But that means we have no class, right?
I did. 2 years ago.
Oh, yeah?
Yeah, for birthdays.
Oh, my gosh.
So it worked out.
So, okay, well, that's Labor Day. We don't have class on Wednesday. We will come back and we will do chapter. Have a nice weekend.
Yeah.
He did say that.
He did say that.